All right, this is the second part of the lesson for today. So, we are just going to talk about what types of triangles can be named when you know the sides of the triangle, and what types of triangles can be made when you know the angle measures. So, I'm going to draw a picture for each one. So, if I have a triangle and none of the sides are congruent, that is something like this. So, if I called this maybe 5, 7, and 9. None of the sides have the same measure. This is scalene. No sides are the same. If you have a triangle with two sides congruent, it says at least two sides. This is how I mark congruent, right? Put hash marks on it. So these two sides are the same. Has a measure of 6 and 6. And this one has a measure of 4. This is called isosceles. And then if all three sides are congruent, all three sides, this is called equilateral. So I'm going to say something that might be weird, but an equilateral triangle is also, by definition, isosceles, because the definition for isosceles is just at least two sides are congruent. Okay? So now let's look at naming triangles by their angles. So 3 angles are acute. Let's say this angle has a measure of 59, this angle has a measure of 61, and this angle has a measure of 60. Acute triangles have all 3 angles that are each less than 90 degrees. Okay, so acute angles are less than 90 degrees. So you see by the angle measures that I put in there, they don't have to be the same, right? If I have 3 congruent angles, all 3 angles are the same, like 60, 60, and 60. This is called an equiangular triangle. 3 congruent angles. And we mark those congruent angles by using this arc kind of, we draw an arc on each angle. If I want to put 2 arcs in each of them, I can. I need to make sure that I mark whichever ones are congruent have the same number of arcs. And then we have what's called a right triangle. So a right triangle has to have one right angle. So this is a right triangle, one right angle. And then the last one is an obtuse triangle. So this is the obtuse angle. And that means that the angle is greater than 90 degrees, but it's less than 180. So I'm going to erase that arrow and triangle, and I'm going to actually put a measure in there. So when we don't know the measure, we put a little circle with a tilde sign in there, and that's called theta. So 90 degrees is less than the measure of the angle. Theta is less than 180. And again, this is an obtuse triangle. So we're using coordinate proofs. There is nothing that I can do on a coordinate proof to prove that an angle is 60 degrees or 59 degrees, but I can prove that an angle is 90 degrees using slope. And then I can show that I have a scalene triangle by using the distance formula, showing all 3 sides are different, or proving that I have an isosceles triangle, showing that 2 sides are the same, or that I have an equilateral triangle, showing that 3 sides are the same. So that is what we're going to do. So let's get to the examples. So our first example, using coordinate geometry, classify triangle ABC as scalene, isosceles, or equilateral. So I have the ordered pair negative 2, 2, which is point A, 2, negative 2, which is point B, and 0, 5, which is point C. So I can tell by looking that this is isosceles, but I have to prove it. So triangle ABC is isosceles by distance. That's what we're going to show. So I'm going to show that triangle ABC is isosceles by using the distance formula. So I have to show that AC is equal to BC. So we're going to use the distance formula. So A, negative 2, C minus 0, the quantity squared, plus A, negative 2 minus 5, the quantity squared. Well, negative 2 minus 0 is negative 2, squared is 4, plus negative 2 minus 5 is negative 7, the quantity squared is 49. What am I doing? So this has the square root of 49 plus 4 is 53. Okay. Guys, I need you to be quiet, please. Sorry, there's a lot going on in the hotel room. I apologize. So B to C. 2 minus 0, the quantity squared, plus negative 2 minus 5, the quantity squared. Well, 2 minus 0 is 2. When I square that, I get 4. Negative 2 and negative 5 is negative 7. Squared is 49. 4 plus 49 is the square root of 53. So we know that triangle ABC is isosceles because AC equals BC. I can also tell by looking that AB is not congruent, but I could show over here that the distance of AB, just to show that it's not equilateral. So A, negative 2 minus 2 squared plus negative 2 plus 2 squared. So negative 4 squared plus 0 squared equals the square root of 16, which is 4. And I can see 1, 2, 3, 4, that AB is in fact 4 units. So triangle ABC is only isosceles. Let's look at example number 2. So I'm going to graph the triangles. Negative 4, negative 2 is point P. Q is negative 1, negative 6. 1, 2, 3, 4, 5, 6. Q. And then R is 6, negative 1, 2, 3. Okay. So it looks like this might be a right triangle. So am I trying to prove that it's a right triangle? Oh, no. Goodness. I'm finding the perimeter. So to find the perimeter, of triangle PQR. Shay, can you please close that door? I must use distance to find the measure of each side. All right. So let's start with the distance of P to Q. So P is negative 4 minus a negative, which is plus 1, the quantity squared, and negative 2 minus a negative, which is plus, 6, the quantity squared. So negative 4 plus 1 is negative 3. Negative 3 squared is 9. Negative 2 plus 6 is 4. 4 squared is 16. 9 plus 16 is 25. So the distance from P to Q is 5. Now let's find the distance of P to R. Okay, so I have -4 minus 6, the quantity squared, plus -2 minus a negative, which is +3, the quantity squared. So -4 minus 6 is -10, squared is 100. -2 plus 3 is 1, squared is 1. So that is the square root of 101. Cannot be simplified. And then the last one is the distance from R to Q. So R is 6 minus a negative, which is +1, the quantity squared, and -3 minus a negative, which is +6, the quantity squared. So 6 plus 1 is 7, squared is 49. -3 plus 6 is 3, squared is 9, which equals the square root of 58. So the perimeter is the sum of all the sides. So it's the square root of 58 plus the square root of 101 plus 5 units, or that is about, let's see, the square root of 58 using a calculator plus the square root of 101 plus 5 is about 22.67 units. Okay. Example number 3 wants me to prove that this is a right triangle. So let's see. U is the ordered pair -3, 3. G is the ordered pair 1, 7. And A is the ordered pair 5, 3. So I need to prove that this is a right triangle. So I'm going to use slope to show that one pair of sides are perpendicular. I'm going to find the slope of all the sides, but really I'm probably trying to prove that UG is perpendicular to GA. So the slope of UG, I'm going to find the slope of UA, and I'm going to find the slope of GA. Okay, so the slope of segment UG, let's see, slope, y coordinate 3 minus 7 over -3 minus 1. 3 minus 7 is -4. -3 minus 1 is -4. So segment UG has a slope of 1. Let's look at segment UA. So 3 minus 3 over -3 minus 5. 3 minus 3 is 0. -3 minus 5 is -8, which means I have a slope of 0. So I know that this line is horizontal, and it is. And then the slope of GA. So if it's perpendicular to UG, it should end up being -1. So let's see, 3 minus 7 over 5 minus 1. 3 minus 7 is -4. 5 minus 1 is 4, which reduces to -1. So triangle UGA forms a right triangle because segment UG is perpendicular to segment GA by slopes. Okay, and I believe that is it. So let's look at your homework. I know there were 2 videos for this lesson. I know it's a lot. So homework. So this is lesson 2.14. You're going to do number 1. And I'm just going to give you a hint. I'm pretty sure that number 1 is a kite. I want you to prove that it's a kite. So look at the notes that we took about showing that something is a kite. And number 2 is a number 2 you should be able to do. It's actually number 5. So this one is a nice shape. We've done it in our homework, in our notes, I mean. Number 6. Easy, you'll be fine with that one. Just trying to see if there are any that I need to give you a hint for. You're also doing the triangle ones. 1, 2, 3, 4 is to find the perimeter. And then you're locating the missing side to make those shapes. So you're finding the 4th point, and that is it. So you have 4 that are just finding the missing ordered pair and justifying it. And then you have 1, 2, 3, 4, 5, 6, 7 coordinate proofs. The only one that's tricky is this one right here. And your hint is that it's a kite. So you'll be able to do that. Look at your notes again and see how to prove that a shape is a kite. All right, good luck. I will see you tomorrow.